Okay, we're going to be very naughty and start 2 minutes early because we have a full room already. Thank you, everyone, for being here. And we have a lot of material to get through, so we're not going to waste any time. Welcome to the Khronos hosted BOF, Forging the Immersive Web, how we're going to bring immersive and spatial technologies to the web platform. But we're thrilled not to be just Khronos here. We have multiple organizations being represented. Because creating standards, particularly for the web, is a team sport. It's a cooperative endeavor. We need standards and open source from many dozens of consortia, standards organizations, open source projects to make spatial computing on the web a reality. So we're going to be hearing from some of the key organizations, W3C, Khronos. We have folks in OpenPBR, who's part of ASWF. We have Mr. Doob himself here for Three.js, some of the most important open source projects. And we're going to try and show not only what we're doing individually, but how we're trying to work together to make the web spatial. So the speakers that we have, I'm Neil. My day job is at NVIDIA. I'm the president of the Khronos Group. We have Atsushi from W3C. We have Greg, who's going to be from Google, who's going to be talking about WebGPU. Ricardo from Google, also talking about Three.js. And we have Julian and Frederick, who are going to be talking about OpenPBR. And we're going to try to keep on time, so we have time for a Q&A at the end of this session. We only have an hour. So let me start with the Khronos updates. A lot of the Khronos standards are used in the web. Perhaps one of the best known ones is glTF. It's the asset transmission format for efficiently providing assets into any application, actually web or native. It's a full-time job keeping this ecosystem slide up to date, but it is very widely used. One of the key things about glTF, of course, it has very well-defined PBR, and so we're working constantly to figure out what the common practice is throughout the industry. We're not inventing new technologies, we're consolidating and precisely defining what the industry is doing around PBR and integrating that into the glTF standard. We have the roadmap that's on the screen there. The new PBR functionality in development is subsurface scattering. So that'll be coming soon. But we are working with other groups doing awesome work in the industry. Material X, which is hosted by the ASWF. We're working to export glTF PBR into a Material X node so people can go between the different PBR systems. We're also looking to use Material X to generate procedural textures for glTF. So in many use cases, that can significantly reduce transmission size. And OpenPBR, we're going to hear about from OpenPBR folks in just a moment. We're working to align what glTF PBR can do and OpenPBR. There are some little differences, so we're working to try and get rid of those. So again, people have the flexibility to use the model they want and move between them as painlessly as possible. glTF, the update is that we're about to have significant roadmap updates. We're essentially upgrading glTF into a spatial computing asset with interactivity, with referencing, so you can build complex scenes, referencing multiple glTFs. That might sound a little bit like USD, but it's not USD. We're very focused on glTF's mission, which is last mile transmission. USD is doing something much larger in terms of cooperative authoring. So we're trying to stick on mission. We think glTF and USD are very complementary. We're building physics into glTF, solid body physics and audio, which is triggered off the interaction graph. The interactivity that we have in glTF is based on a graph node system, so it's easy to author, and the graphics and the audio can run off that same graph. So it's a lot of functionality coming. So we're trying to work with the engine vendors and the tool vendors to make sure that all this functionality is reliably and consistently implemented across the industry. We're also finding that glTF is being used as a foundational standard by other standards organizations building on top of glTF. So that's about 2 years ago, glTF became an ISO standard. That's an international formal standard. And that triggered interest from many other standards organizations to build glTF into their activities. So VRM, which is here in Japan, an avatar format that's very widely adopted, is based on top of glTF2. And we actually have a joint BOF with them on Friday. So if you're interested in that, please come. Gucci-san from VRM is going to be talking. 3D tiles, for example, from the OpenGL Spatial Consortium, entirely based on glTF. And it's something we very much welcome. The domain experts in a particular domain and using and referencing glTF. Even PDF, now we're an ISO standard, PDF can reference us, so PDF now supports glTF 3D models. We're not just focused on the asset format itself, we're trying to help build out the ecosystem on how glTF gets deployed. One gap in the ecosystem we found, and shout out to Emmett Gareth at Google for the PBR neutral tone mapper. There are multiple tone mappers in the industry. Turns out that most of them are based on displaying movies or images. There was no tone mapper to accurately display the colors of a PBR 3D generated model. We were finding that the colors weren't being displayed accurately. A lot of the color space was being washed out. And so Emmett has created this. It's become a Khronos recommended practice, and it's already widely adopted by multiple tools and engines. So hopefully good value to the industry. We also have a 3D commerce group at Khronos, which is trying to do the same kind of thing. It's trying to make 3D reliable, not just at the format level, but at the deployment level. So as well as the tone mapper, we're putting together asset library, which is really like a conformance test suite for an asset format. All the engines and the players and the applications can use the asset library to test their functionality. Again, working with Emmett from Google, we have now the render showcase, so we can have multiple engines being displayed side by side in a website to find early if some of the engines are displaying things differently to other engines. Sometimes they want to, but if they want to be consistent, this is a way to figure out that something may be wrong, and we can help the engines have correct glTF functionality. We have a sample viewer, we have a validator, so people creating glTF assets can test that the glTF is well formed, and this is this is a job for life to keep this moving forward as glTF evolves. So I wanted just to do a quick shout out to the Metaverse Standards Forum, which is another organization, but it is unique amongst the other ones we've already mentioned. It's not a standards organization. It's just a place, it's a place for standards organizations in the industry to come together in a neutral place and actually talk, collaborate and cooperate on how we can actually work together effectively. We can't, none of these groups can do it all by themselves. We need to align, leverage each other's work, and assist each other where we can. One example is, well, the Metaverse Standards Forum has about 20 domain groups working on different areas. One that's particularly interesting, I think, to this audience is that we have the glTF, it's very imaginative name, glTF USD 3D Asset Interoperability Working Group, but the name is very descriptive. It's the USD and the glTF communities coming together all in one place. As many members as want from either side are welcome to participate, and we are figuring out how to work together, making sure, for example, that the roadmaps of USD and glTF are aligned as possible. If we have roadmap functionality that is similar on both sides, let's talk to make sure that we don't do it arbitrarily differently, just for no good reason, because we didn't communicate well enough. And that's been running for around 2 years now. And I think it's genuinely created a real community that includes the USD and the glTF folks. And we want to see that continue. The forum is open to everyone, just like all of the standards organizations you're going to see today, open to anyone who wants to join. So please do consider getting involved if you can. The other big web standard, of course, is from Khronos, is WebGL. WebGPU is going to replace WebGL, and WebGL is a Khronos standard. WebGPU is a W3C standard, but that's okay. That's good. Khronos fully supports developers having a smooth transition path from WebGL to WebGPU. And again, we're wanting to work closely with W3C to we can do everything we can to make sure that that transition is made as smooth as possible. But WebGPU is going to take a while to roll out to be as pervasive as WebGL. WebGL is now available in 97% of browsers. And WebGL is going to be around, it's probably going to be around for longer than I am, for decades. And WebGL is not being ignored at Khronos. We want to make sure that WebGL is a stable, reliable API throughout its entire lifetime. So we're actually adding functionality, adding performance tests, and making sure that WebGL remains a reliable platform for as long as it's needed, which I think is going to be a very long time. But WebGPU is the new 3D, which you're going to hear about from Gray. WebXR, of course, is bringing XR capability onto the web. Both are W3C initiatives. But I think we found a good kind of working pattern where Khronos works on the native APIs and the W3C lists those APIs up into JavaScript for the web stack. And that's, I think, a very productive and logical way of doing things in the future. So it's a cooperation that we very much welcome. My last slide is that our newest initiative from Khronos, which we just had a buff on, the Slang open source cross-platform compiler. It's a compiler and a language that can deliver cutting-edge language capabilities, modularity, auto-differentiation for neural rendering, but it has a whole bunch of output targets. So for the first time, a single integrated compiler chain can give you all of these targets in one place without having to put together multiple modules in a tool chain. And WebGL is supported as one of those outputs. It's a recent addition, but it's very interesting. I would love to have we don't know how the WebGPU community, if and how the WebGPU community is going to find value in Slang. But if it does, we'd love to have that conversation and to figure out what we can do in Slang to make it more valuable to the WebGPU community. So that's enough for me. I'm going to hand it now over to Atsushi from W3C.
Introduction and cooperation between RCC and Khronos. So I'd like to give an overview and recent updates about the immersive web activity in W3C. So, sorry for a bit smaller character, but immersive web activity at W3C is organized by two or three groups, and most of recommendation specification development is doing under a working group, but we have companion committee group open to the public, and proposals discussed under the committee group. So everyone can present the proposals or any new ideas to there. And also several new ideas also bring from Khronos or many other organizations, including OGC is working for spatial computing and data, bringing spatial communication like metaverse related ones into immersive web areas. And also W3C operates workshops around 2 or 3 times per year over all over picking up several topics all over the web. So we did a workshop around the game, including WebXR or any XR topics in 2019, and several new proposals are bringing into the WebXR. And also, of course, we are closely working together with glTF, OpenXR, and also WebGPU, as well as the OpenUSD. So this is a current overview of the WebXR stack. So at the bottom of the WebXR stack is a WebXR device API. This is sometimes called as a core API, which defines on top JavaScript modules over OpenXR. So this connects OpenXR into JavaScript space. So many input system or defining a view, including selection between VR or AR mode, are defined in these core modules, and many extension modules defined on top of that, layouted at the upper half of this slide. So there are many input modules, including exposing game parts into the XR space, or hand input module to detect to present detected hand pose into XR space, or this is tied together between JavaScript XR and web space. So several modules like DOM overlays modules enable the showing DOM elements picking up from one DOM3 of the web page into the XR session, or layers API enables to show layers like a cylinder or a square or many other layers into XR space. So the device API core module itself is already get stable and will not have a bunch of updates from now, but many other modules and emerging modules like marker tracking is a 3D marker tracking on top of the WebXR. Something like such kind of modules will be added into the WebXR stack. This is our organization to enable XR on the web. So for recent updates, most of the WebXR device API is already stable. So it's almost no update since 2021, over 3 years. But many some new emerging modes like WebGPU integration into WebXR Core API is under discussion for the final shape. And also many other modules, including a model element, which enables native glTF or USD display on the website or browser, or some other modules under discussion to enable more features into the WebXR space. So for the picking 2 or 3 items from recent updates, so I'd like to introduce one. So WebGPU is an emerging technology. We'll have a talk from one of the co-chairs right after me, but originally, WebGL was supported as a WebXR WebGL layers in WebXR stack, but recently there are some misalignment of data format between two. So we had a bunch of discussions over years to enable WebGPU in WebXR space. So WebXR working group have some mutual understanding about enabling WebGPU natively in WebXR space. So we are now finalizing about this and had a bunch of discussion about this topic on TPAC this year. And the second is model element. As I said, this is proposed for a native display within browser for glTF or USD. So without any JavaScript required. So originally this was proposed under Games for the Web workshop in 2019. And also recently emerging hardware development. This was emerging topic with WebXR. So working group is hoping to welcome this new element into HTML in relatively short time scale. So, and then I'd like to introduce one key Japanese community member. Hi, Aiko-san.
Hi, I'm Iko from Tokyo, Japan. I'm a developer in Japan WebXR communities. And so I took expectation for the Immersive Web from WebXR Japanese community. Please give me 3 or 4 minutes. And there is an active community about the XR and events open here. For example, this month we will host XR Kai. Do you know XR Kai? Okay. And XR Kai is the largest XR event in Japan. And also on December 21st, there will be 2 VR chat events. And the same day, I will host WebXR Talk. WebXR Talk have some of WebXR contents and WebXR talks. And companies and organizations associated with XR are excited. As you know, BRM, do you have BRM avatars?
Yes.
Oh, yeah, good. So good. Yeah, BRM is a format for 3D avatars from Japan. Is based glTF. And Pixie is a Japanese company, provides a 3BRM, and you can use 3BRM, and we can use 100 BRM with WebXR. And Paran is a Japanese company specialized in WebXR. The WebXR solutions use through Japan. For example, now we can play the Steins Gate's WebXR games. And also there is an individual developer using WebXR. For example, Nini-san is a good developer using Babylon.js and WebXR device API. He will talk about WebXR device API and XR Kai. And Work Factory-san is a developer of Spatial Shell. Spatial Shell is a playground for WebXR. And I organized a WebXR Advent Calendar this year. And last, I expect WebXR to exciting for the Apple Vision Pro. Yeah, supports WebXR by APIs. And next year, we plan to hold the WebXR Developer Conference, Tokyo, in Japan. And I would like to see more interaction between developers who are using the game engine, like Unity or Xcode and Swift developers, and web front engineer using JavaScript. Thank you.
And we welcome many people in community to event in Tokyo. And also, please note that this red icon is a WebXR icon. Do you know? I brought a sticker of this icon and placed at the table outside this room. So please pick one. And thank you so much for today, and welcome Greg-san for WebGPU from one of our WebGPU co-chairs in WCC.
Hello. So who here has, you've all heard of WebGPU? Yes? Anybody not heard of WebGPU? Just a quick overview WebGPU is cross-platform. That is the number one thing I want to share with you. It's implemented on top of whatever the native platform is. So, DirectX on Windows, Vulkan on Android, and Linux, Metal on iOS and Mac OS, and OpenGL, which I'll get to in a bit. It's currently running on Windows, Mac, Linux, Chrome OS, Android, and iOS. Maybe some other platforms soon. It's shipping in Chrome and Edge, coming soon in Firefox and Safari, hopefully very soon. And you may have heard it's got its own shading language, WGL, or the WebGPU shading language. Oops. A diagram from a website that showed this off, showing various levels with WebGPU JavaScript API at the top and going through various ways to get all the way down to the GPU drivers. So who here has actually programmed WebGPU? Anybody? Few people. Okay. I wanted to give you a quick overview because I enjoy WebGPU a lot, more than I enjoyed some other APIs. There's been a lot of effort, at least in Dawn, and I'm sure in WebGPU, which I'll go over later, those two implementations to give you good error messages. So it's easy to use. This is Hello Triangle in 60 seconds, so I'm going to go over it really quick. You create an adapter, which is your GPU card, and then you make a device. In the browser, you would set up the canvas to say you want to work with WebGPU. Here we're compiling a shader using WGL, so that is a vertex shader and a fragment shader. Here we're creating a pipeline to say which vertex shader and fragment shader to use, and that they're going to output to RGBA even norm texture. Like most modern APIs, WebGPU works with command buffers, so this is creating a command buffer encoder. And then we are going to start a render pass. In this case, we're going to tell it, using a render pass, which texture we want to render to. This one is getting a texture from the canvas, so we can render directly into the canvas. We tell it to use the pipeline we set up earlier and draw 3 vertices and end that pass. And then we say, execute this command buffer and all the commands in it. And we get a triangle. This is the fanciest graphics I have. I mean, you can literally put something together that quick. And if you mess up, it'll hopefully give you really good error messages. Just coming from if you're from an OpenGL world where all you would get is, GL invalid operation, and you have no clue where that came from, we get much nicer error messages. So something I want to emphasize is that WebGPU, this is the immersive web thing, but WebGPU is not just the web. It runs in Node, it runs in Dino, it runs in React Native. Google has a C++ implementation called Dawn, which is what we use in Chrome. And so if you want to make a C++ app, a native C++ app, and you want it to run on all those platforms, you can just use Dawn and do it that way. If you're into Rust, you can use WGPU, which is by the Mozilla folks. And same thing, you can compile it to a native app. You can compile Rust through Mscripton to the web as well. So you can get all of those platforms for free. There are Python bindings, there are Go bindings, and there are Java and Kotlin bindings coming. I know that there are other ones. I've seen somebody hook it up to Zig, and I've seen people hook it up to other languages. But the point is that it's cross-platform. So if you hook it up, then immediately you get modern graphics on all these platforms. So WebGPU shipped in Chrome almost a year and a half ago. It was May of 2023. And since that time, a few things have been added. Color spaces are out there. You can do more than just sRGB. HDR is out there. There are already live demos on the WebGPU sample site. So the easiest way to see that is if you have probably a MacBook, since they by default have an HDR display, or maybe an Android, and iOS devices usually have those displays. You can, that's the HDR, come on, yes, you can get bright images. Intentional, no. Clip distances were added, dual source blending, so you can do fancier blending than the defaults. We just put in more vertex formats just the other day to make it parity with some of the formats that were in WebGL. F16 support is in there, and dot product of 4 elements and accumulate is something very useful for speeding up LLM stuff. And those have all shipped. Coming soon, well, Safari, there's rumors it's going to be very soon, but they don't give dates, so you never know. But you can turn it on now, and so you can turn it on through in the developer menu in both iOS and on macOS, and you can see it work and find out where it's broken and file bugs if it is. Firefox is also coming along very quickly. And something I work on a lot is the conformance test suite, which is huge. It's got millions of tests. I think individually it's got over 200,000. Takes 3 hours to run, and we're trying to make sure that they are all compatible with each other. And there's still more being added. Multi-draw indirect lets you set up a whole bunch of draw calls, which you've from a buffer, and that is something that you can fill out a buffer from a shader, which means that will enable a whole bunch of more modern features, figuring out what you want to render in a compute shader and then passing it on to their other shaders to draw everything. Subgroups, which if you're not familiar, they let you coordinate threads, individual threads inside of a compute shader, are experimental now, and so coming soon. And then Compat. Compat is running WebGPU on OpenGL AS. And this is basically to bring WebGPU back to all the devices that run on WebGL 2. It has some limits, but if you want to be able to reach all those 96% of all devices out there, but be able to use all the modern features and at least be able to use compute shaders, then this will be a path that you can do that. We're trying to get that standard finished ASAP and shipped. So we'll see what happens. And XR. Brandon Jones, who works on XR on Chrome, basically said it's already shipping. Well, not shipping. It's not shipping in stable. You can already use it in Android. He said he can't promise this, but he said maybe by the end of the week you can run it in Windows. But basically, you go into the About flags in Chrome and turn it on, and you can test it now. They're looking for developer feedback, what's missing, what's not working. He said that there are already some known performance bumps and optimization issues. But yes, if you want to know what's going on there, there's a link. And if you want some minimal samples, probably put like a sphere in front of you and be able to touch it or something. Those are already up. And you can test them today. The other thing is we had a face-to-face meeting where all the browser vendors and other interested parties got together and talked. And this is a photo of probably the last thing we talked about is what are we going to do next? So these are all aspirational, but I would say number one on that list is probably bindless. Bindless lets you have thousands of textures available as opposed to the current limit, which is like 16 or 32, and is used by most modern rendering engines to get uber speed. So we definitely have that at the top of the list. Subgroups I already mentioned, they're in experiment now and just getting that experiment finalized. Things like push constants are a speed up. Subgroup matrix is something that is useful for LLMs and getting more and more speed. And yeah, other things. UMA is trying to keep the number of copies down so you can actually map a buffer into JavaScript or the other APIs, the native ones. Right now, some of those things are copies, but we're trying to find a way to make that available to everybody. 64-bit atomics is a feature that's used a lot in things like nanites and those kind of renderers where they render little meshlets. And so, yeah, we will try to get as much as that as we can in as fast as we can. And my last slide is just a bunch of links. If you want to know what the spec is, how Wixel looks, if you want to discuss the spec, if you want to see all the tests, and which you can actually, there's a link there, you can run them live if you want. Your machine will take hours to run them, because when I mentioned 3 hours, that was spread across a whole bunch of devices. If you want Don, if you want to do C++, there's the Don link. If you want to use WebGPU for Rust, there's the WGPU link. If you want to use React Native, they have working demos in React Native with mobile apps running. There's a sample site and there's some tutorials, and you can learn about it real quick. They start very simple, like that basic hello triangle is the first sample. Yeah, but the thing that I really wanted to emphasize again is that this is cross-platform. And so you can get a lot of mileage out of that. If you really prefer writing in C++ or Rust or one of those other languages, you can start there. You can have your app run everywhere. I would really like to see, I'd hope this would happen with WebGL and WebGL2, and maybe because we were missing compute shaders, I hope this will happen with WebGPU, but it'd be awesome if all these papers we're seeing had actual live samples. You could go click on a web page and see their sample run live. And hopefully we're enabling that. A lot of them are native bound, but I don't think they have to be. And so hopefully WebGPU will make that happen. Cool. Right.
Thank you.
And next up is
Ricardo from Google as well.
hello everyone, thank you for coming. Ricardo, I've been running the Three.js project for the last 14 years. Interesting. So I'm going to give a little bit of an update with the work that we've been doing for the last, I guess, 3 years now. We're doing a render, like a WebGPU render for Three.js. These are all the people that have been working over the last, especially the last months. What we're trying to do basically is to try to get all your usual like JavaScript app or the usual Three.js app that we want to get it. So you only have to replace the render and it looks the same thing, but there are limitations, like especially you were using like GLSL or like custom like shaded materials. It's something that we're still now like trying. We're looking for option for getting that to work on WebGPU, but the idea like for now, like the goal is to only have to replace that. So we try to like we started working on the render, like WebGPU render, to try to get to start to adopt the new API. But the problem is that like, we can't have a renderer that is like a WebGPU render and also a WebGL render, but then because of the browser support, then people are going to have to do any app that they have, or any JavaScript app that they have, they're going to have to check if it's available one, use the WebGL render, or use if it's not available, use the WebGPU render. And that's something that, is like an API, is like a code that we don't want people to do. So basically, we ended up like having like a WebGL2 fallback inside the new WebGPU render. Not only for the support, not only for like so people don't have to worry about like whether if it wasn't Safari or not, but also like even if one like Safari support is going to be hardware that's not going to work. It's not going to work on some stuff until like WebGPU compat gets there. But like we are all kind of trying to work our way for helping developers to not have to worry about this support stuff. So the idea also is like if people start using WebGPU render and they deploy the code is going to be online and it's going to be using the WebGL fallback in Firefox and Safari. But whenever they enable it, then the code path of the WebGPU render is going to start being using. So it's a bit like, I guess, like doing a Trojan or a virus, something like that. And there's a third problem that in this case we have like GLSL and also WSL. So how do you, if you're doing like a material or you're doing like some custom shader, how do you end up like, and you have like two backends, how do you end up like supporting both of them? So I'm sure like everyone have seen this before. So we ended up like doing our own like Json language. It's not based, I was not like, it's not something that I wanted to do, but I think it started to make a lot of sense. So it's basically node-based JavaScript shaders. It generates, like you write JavaScript and it generates like GLSL or WSL, depending on the backend that the render is using. And it looks, maybe it's a bit small, but it looks something like this. Basically, you're importing from the 3.tsl, you import the classes or the function that you're going to be using on your shader. And like in this case, in this case, we're basically creating a texture, and we're basically adding like a texture, like another texture on top of it for adding detail, like multiplying the color from like two different textures. And then we applying that result to the color node, and then the material is going to do all the shading and band mapping and like tone mapping, whatever that needs to do. This is something that also allows us to have like tree shaking, which is something that a problem that we had in the past, where the WebGL render had all the shaders that the materials use. So if you only were using like a material that had lines, you had to like your app will still be like 170 kilobytes because we cannot like tree shake all the other. Even if you're just using PBR, we had to include that. That was a problem with my design of the renderer. So in this case, you're only using like texture from TSL, like all the other functions in none be included. This allows to have like now very easy way to like have procedural, in this case like procedural gradient. So you want to do like a background, like you use a sphere with a background, and you want to have a base like a simple sky. You only have to do like we had this kind of like a bit of magic, but we had these properties that allow you to use that to make a gradient from top to bottom in the red, like basically a red color, like top to bottom gradients. And it allows something like that. Like before, you had to like use a canvas 2D for creating gradient, or you had to like load an image, or like do your custom shader for that. But like I think this is going to be much easier for that. And it also like allows doing like procedural textures. So ideally, it would be nice if we could do, if the API will look something like this, where you have like model, and you basically on the color node you apply a function that is basically with, and then you actually have an example of that, and then you end up with like having something like this. The nice thing of also this approach is because all those things are like shader based. It's also like, as everyone knows here, it's infinite quality. So you can generate a lot of textures without having to worry about like download size, and also like, you could probably, depend on your case, you don't have to generate an every frame, which is what's happening here. But that's something that it's kind of allows to do that. So whenever we have this, what's interesting, what I found interesting is the fact that we can benefit from the NPM. So basically, we can create a shader ecosystem of NPM. So we can do something like this where, from some NPM repo, like an NPM, we can import like something will be like TSL texture, and then there you can have like different textures that we can import to and use directly. So it's very like nice to compose different nodes and different, like for people to create objects for that. So, and that's actually something that Pavel is something that he has really worked on that. So this was the demo of that, and he also had like this site where you can go to, let's say, the Marvel one. You can see how it looks like. I think it's this one. Yeah. And here you can see basically how you import like Marvel from the TSL texture package, and then these are the properties that you had to do, and they kind of like examples that you can do. We also like implementing compute. It's something which is work in progress. So the pathway that is computer sync. So there's a lot of examples you can see already on the website. This is like something like Khronos Group has done. Like most of them is playing with particles. There's another one. A lot of fancy stuff, and also like one that is like based. Poor guy. And finally, also we have a material X loader. Like now, if it's like nodes like shaders, like we also might have a material X loader, which basically will load the material X definition. We like convert it to our own like node materials. We heard a lot about Slang. We still don't know how this is going to combine with this. It's something that I'm having a look at. Maybe we can import it as a like node. We'll see. We'll have to like see how we can work on that. But yeah, that's the update. Thank you very much.
Cool. So, like I said, quick status update. Where is the next person? Yeah, space everything. Okay. So, quick overview of some of the features, state of the integration into the products, and finally, and quite importantly, the future of the product. But first, what is OpenPBR? You may ask. To give you an example, if you're an artist and you export something, say from Substance Painter to Arnold, you don't want to have to retweak your asset because the look has changed slightly in very like subtle ways. And yet, when I was working in the video game industry, I saw a lot of my colleagues spend a lot of time doing this. And since Autodesk and Adobe share a large user base, it makes sense to try to solve this problem. So as a solution, we try to merge the material models used on the Autodesk side and the Adobe side. And that way the exchange of assets from between our tools becomes easier. But the problem I described, having to do additional work when exporting materials from one tool to another, happens every time you have a different material model between those tools. So to avoid having the problem repeating itself, we wanted to have an open governance so that the rest of the industry could also join and participate into the discussion. And that's how OpenPBR was created. So it is physically based. And since our users create material, they don't only use it, they really create them, it needed to be artist friendly. And when it comes to use cases between Adobe and Autodesk, we have many different use cases. As an example, Arnold is used a lot in the film industry, and Substance has a very strong foothold in the video game industry. So we wanted a model that is agnostic to the use. Essentially, you describe a material, what the intended look is, and that material can then be used, whether it's in offline rendering, in video game, in virtual reality, web, etc., you name it. So to give a very brief timeline overview of that project, this is a work we started 2 years ago. Essentially, at the end of 22, we started talking to each other. We wrote a first draft specification. We joined the Academic Software Foundation under as a Material X project. We did reviews with the industry actors that joined the discussion, and finally we announced publicly the project at SIGGRAPH 23 last year, and published a first draft version soon after that. The version 1.0 of the project was published last June. And at this point, we have a finalized version 1.1. We have a unified model. That model improves over both the Autodesk and Adobe models. I'll give some example in a second. We have a Material X reference implementation. So essentially what Ricardo was showing a moment ago, we can have the same with OpenPBR. That means if your tool supports Material X, you're actually pretty close to also supporting OpenPBR. And as far as we can tell, there is a major interest from vendors to support it and from end users. So we're really happy with where this is, how this is going. And this is how it looks, by the way. I'm not going to go over here. We have very limited time, but essentially, this is a very long document describing all the details of the material and what they mean and how they're supposed to look like, and it's all posted on a GitHub repository. That illustration that you see many times with OpenPBR publications, that's an artwork from Nikki Monteleone, who created this asset so we could check between Adobe and Autodesk that we had a matching look. I'll go very quickly over some of the features to showcase a little bit what has changed. So first one would be expressivity. With OpenPBR, we can describe things that we couldn't describe in the previous models. So this example here shows how we change the layering, and that allows to have, for example, dust on top of metal, which was not possible before in our models. Another feature is energy conservation. It's a physically based model. This is super important to us. And as an example of that, we have this new energy preserving Oren-Nayar diffuse model, which is the work of Peter, Jamie, and Stephen, and has been submitted separately as a paper. It's currently under review. So quite a cool thing to have there. Other feature would be art directability. So one example of that is the tint model we have for the middle Fresnel. There is a well-known Gulbrandsen model, but this model has a limitation, which is that the color you put for the edge that the artist puts is not the color that you have in the end. So it lacks a little bit of intuitiveness here. So instead we use the F82 tint, and what the color that the artist puts is what they get in the end on the result. Expressivity again. So for the first layer, we picked the Zeltner Flex-based BASDF that is used by Disney, and it has a wider palette of looks than the model that was used before by our models. trade-off between physically based and art directable. So here an example with a coating. Typically, when you have coating, you will have darkening of the underneath layer. So think of a puddle of water on the ground. It's going to darken the look. So our model expresses that. So we have a model for that, but the artist might not be happy with how they look, how it looks. So the model exposes a control so they can tweak it or even remove it entirely. And finally, sometimes you want to express a certain effect, either in an artist-directable, artist-intuitive way, or you want to input physical units. That's the case of dispersion with the AB number. And to solve that issue in OpenPBR, we have the dispersion that can be expressed both ways. And with that, I will hand it to Frédéric to talk about the integration.
Thanks, Julien. So, okay, that's cool. How do you integrate OpenPBR in your app? So the easiest way is to use MaterialX because it's integrated in some versions of MaterialX. I'll go in details later. But I want to highlight that the white paper describes the model in maths, in drawings and English, so you can implement it without MaterialX. It's designed for this, and it's written for implemented. So you should have everything to guide you to implement it from scratch if you want, or you could leverage MaterialX. So if you want to use it today, well, it depends if you want to use USD with it or not. With the current version of USD, 24.11, you can use a backport of OpenPBR in MaterialX 138. In the future, with the next version of OpenUSD, should support the greatest and latest MaterialX 135 with a full definition of OpenPBR. I just want to add that we managed to sneak in also translation graphs in MaterialX so that you can convert your assets from and to standard surface. All right, let's have a look at a few of the ongoing integrations. So most of those are work in progress, so they're not shipped yet, but just to show you how it's been integrated in various products that you might know. So this is a work in progress of the integration in Substance, in Adobe Substance. This is how it looks in Arnold, Autodesk Arnold, and this is shipping now actually. So that gives you access to OpenPBR in Arnold in all the applications we support. So it's Maya, 3ds Max, Houdini, Cinema 4D, Katana. Also, you have it natively in Maya and Max, in the viewport and as shaders. Okay, here's also a preview of the integration of an earlier version of OpenPBR in NVIDIA Omniverse. And lastly, I want to show it inside of SideFX Karma in Houdini with the Karma renderer. Okay, so what's next for OpenPBR? So after we released the spec, we got lots of feedback from the community, and there's some very current topics that I discussed right now. Most of the community thought that those two features were really direly missing to represent, especially to the product visualization. So rich reflectivity and flakes and glints were very important and not part of the model. So we're discussing right now how to integrate those in the model. We also got lots of questions, and actually that's the reason we're here, because we didn't talk a lot about web, as you can see, but a lot of people are interested to have a real-time representation of OpenPBR for various reasons, on the web, for interactive applications, and yeah, they need guidance for approximation. So we're working on this topic very actively now. Also, yeah, and how do you author this? Like, I give you an example that will speak to everyone. Ambient occlusion is very often included in models, but ambient occlusion is a hack. You don't need it. It's not part of the it's not part of the material. But we don't want to be pedantic. It's actually defining the look of an asset, and we want to transport this. OpenPBR is all about preserving the intent of the look of an asset so that you can display it like to the your best capacity in any target. But the intent of the look will remain, right? Speaking of visual fidelity, that's also a very current topic. How do you measure the visual fidelity? How do you test to measure if your implementation is compliant or how much it is compliant, right? And future-looking projects also is OpenPBR beyond surfaces. We want to exchange assets between studios, between applications for production rendering. So we need more than surfaces. We want volumes and how to do explosion, flow, etc. And that concludes our presentation. So yeah, contributions welcome. It's all open. You can participate to the meetings, and there's a repo. Your PRs are most welcome.
Thank you.
Thank you.
We didn't do bad. We have a few minutes of questions. So for any of the speakers. So Mark.
I have two related questions. One, I guess, for Greg. Why did WebGPU decide to do another source shading language, as opposed to say, I'm not trying to start a flame war. I'm interested in why you chose another high-level language rather than Sphere going for an intermediate language.
I can only give my own personal thoughts on that because I wasn't there for the decision. I've only heard some hearsay. But I do know that getting Sphere V to be portable and safe is harder than starting from scratch because we're on the web. Any random ad can decide to use WebGPU unless you use a browser that lets you block it. And so by having our own language, we could make sure that only the features that we can be secure there, and we could set our own direction. We didn't have to wait for some other community to approve it and add whatever features we needed. So it let us go faster. I think those are the number one reasons.
Thank you. The other question is sort of related. Mr. Du touched on it, and it's about slang support for TSL. I don't know if Shannon's still in the room.
No, I don't think so.
I don't have much to say on that. It's just pretty something that we like this material slang with TSL is like all the different language. We're gonna have to we're aware that we had to make it easy to go from one to the other one. But it's for me like kind of like a non-new thing that I still had to wrap my head around.
My impression from the snippets you showed in your presentation is that it's quite significantly different from other shading languages.
Yes,
so I mean we're a struggle for slang.
We're targeting more like JavaScript developers, it's different type of people, but if someone writes some material with slang, for instance, that someone wants to reuse, we should be able to make it either have a way to convert it easily, or if that becomes a thing, this whole ecosystem to also be adopted. But we'll keep an eye on that.
Thank you.
Yeah. Any other questions? Yeah, over there.
Hi, so my question is, how is OpenPBR going to work with glTF's PBR system? And I know you're asking about real-time in the web, and I'm just curious, because I have a program where we do texture painting on models, and so they'll come in with PBR from one tool, they paint in our tool, then we export and they go to another tool, and it's it can look different on all three. So.
Yeah, that's a great question. My understanding on what we're doing on the glTF front. So originally we were hoping that maybe there would be some adoption, but in the end, it doesn't look like this is happening. So my understanding is the way we're going forward is there is a group discussing in the glTF, the discussion group, to make sure that we have the extensions that allow to support what we define in OpenPBR because we have a bunch of new BSDFs, as you saw. So that means adding them to the different backends, and we have a discussion with glTF to have support for those as well.
Yeah, I'd like to add. It's a good question. It's the $1 million question. How can I author something somewhere and it looks the same everywhere? So short answer, it's never going to work because you don't have the same compute power and you don't have the same desire. Like you want something real time or you want something to look good for a movie. So that's different intent. I think glTF PBR and OpenPBR are coming from different objectives. For OpenPBR, it was to support our industry of high-end visuals for movies, etc. But it leaks into games and other stuff, and that's why we're here. But we want all the features that you need for production rendering in our space. Example, subsurface scattering. So yeah, we need it. We absolutely need it. That's a must. Whereas for glTF PBR, it's not the first thing. And also, I would say, yeah, glTF PBR, in my opinion, is more about the last mile. So you would express things to be in like you would translate to glTF PBR before that. Whereas we're a bit of both. We're focused on the authoring a bit more. Right. I hope that answers your question.
I'd like to add to that, and I actually agree with you. I mean, the OpenPBR is coming from the high end. The mission of glTF PBR is to encapsulate what is possible to run on a mobile phone, and that's a wavefront that moves forward. The key, though, for the developers is we need these guys to do all the cool stuff up at the high end. So the pipeline is full. So eventually it becomes needed on mobile phones and the web. So, and glTF can appropriately bring that into the glTF standard that makes it available on a bunch more platforms, additional platforms. The key, though, is to try, as both evolve, not to have senseless differences that makes the translation from one to the other or the movement from one system to the other impossibly difficult. That's why we need to cooperate. We need both, but we need cooperation between the two, is my answer. I think we have time maybe for one more question. And all the speakers, I hope, are going to hang around for a few minutes. So we'll be outside. There's another session in here. We'll have to get out, but please hang around and chat with the speakers. But yeah, go ahead.
Hello, this is like a WebXR developer. So my question is on iOS system or like a Safari system. So far, WebXR is not very supported yet. So do you know any like timeline for that? And
Easy question.
The polyfill. Right now in the immersive web, the polyfill is very old. I mean, it's 4 years ago. Like there's not too much the modern TypeScript like a type of thing, and also a lot of like module doesn't have the support in polyfill as well, and especially for AR. And is there any way as a contributor we can contribute from outside for that and to improve the system stability? Yeah.
For Apple implementation, I heard that some implementation is working for Apple Vision Pro.
Yes,
yeah.
for the iOS.
Yeah. So and I heard some flagged implementation exists, but I don't have anything I can say here. And for profile, sorry, but the working groups and community groups within W3C recently has a small amount of resources working for, as example, of profile. So any contribution is welcome via GitHub repositories. So yeah, please feel contact to working group for me. I'm a team contact for working groups, so I can connect anyone to the groups.
I'm sure there are more questions, but let's take them outside. Thank you to all the speakers. Thank you to all for coming. Thank you.